The first big sky event I remember seeing was the Perseid meteor shower. It was the summer between second and third grade, and we'd been at a neighbor's playing games. As we were leaving, my dad mentioned in passing, "There's a meteor shower." And we all traipsed out to the lawn to look up. Sure enough, streak, streak, streak. Bits of former comet shot across the sky, creating shooting stars, the first shooting stars I'd ever seen. This year, we can expect about 100 meteors an hour when the Perseids peak on August 12th. And the meteors can be seen in lower frequency for a couple of weeks both before and after peak. If you miss the Perseids, don't worry. This December's Geminids, they peak December 13th and 14th, and they're going to put on an even bigger show. Getting out and looking up is a good way to remember that we're part of this universe. In this show, I'll be talking about a weird white dwarf that is doing things our sun may do billions of years from now. I'll be talking about how satellite images can now be used to measure river flows here and on Mars and on Titan. And I'll be talking about the emerging field of planetary geoarcheology that will help us understand just how long it will take for Mars rovers to become buried relics. It's all of a single cloth, and our world is just one more planet among billions. It's also the only planet we can live on right now. In our closer look, I'll also talk about how our climate could change in the future and what that means. The future isn't great, and I didn't enjoy researching this episode. But sometimes we have to look at the ugly parts of science as well as the beautiful. This is Escape Velocity Space News, and I am your host, Dr. Pamela Gay, and I am here to put science in your brain. The results of science are often weirder than anything humans can imagine. As researchers, we dedicate our lives to taking data and knowing that whatever we may want to believe, we have to accept the reality of what our data shows us. And sometimes the data is just plain weird. The press release for our first story comes with the quote, "When I show observations to people, they are blown away." And in describing those results, the press officers explain, quote, "The team acknowledges they are baffled, but have come up with some possible theories." While looking for stars with strong magnetic fields, researchers found a white dwarf that varies in brightness in a way that white dwarfs usually don't vary. This wasn't the high-speed pulsations that have been seen before. Rather, about every 15 minutes, they observed the star's brightness to vary. This duration isn't consistent with anything previously seen. And in follow-up observations, the team studied the star's composition to see how else things may differ from your run-of-the-mill white dwarf. And remarkably, the two sides of the star differ in composition, with one side being predominantly hydrogen while the other is predominantly helium. This is a new kind of weird. We've known for decades that some white dwarfs have hydrogen atmospheres while others have helium. We also know that below 30,000 degrees Kelvin, many helium-dominated atmospheres become hydrogen-dominated. Exactly why this happens, we're still learning, but it's thought the helium sinks over time. This entirely weird white dwarf, which the team has named Janus because of its two-faced nature, is currently 35,000 Kelvin. As best as anyone can figure, Janus has a small magnetic field that causes one side of the star to be a little bit warmer than the other. This temperature variation may in turn cause the cooler side to have already lost its helium to become hydrogen dominated, while the warmer side has continued to support its helium atmosphere. This discovery is published in the journal Nature and led by Ilari Kayazo. It was Kayazo who pointed out these results blow people away. The universe is large, and the things we are most likely to see are the things that are common and the things that last for a long period of time. While many stars become white dwarfs after nuclear reactions cease in their cores, only some of them start as helium white dwarfs. And of those, only some transition to hydrogen white dwarfs. And the transition is likely brief on the scale of the universe. And it happens as the white dwarf cools. It is truly remarkable that we caught a white dwarf with just the right combination of elements and with just the right alignment of a magnetic field and at just the right time in its cooling. But the more we look at the universe, the more we'll be able to see and find these kinds of rare and wonderful things. In an attempt to see and track down more rare events, researchers have installed a special instrument called VLIGHT at the Very Large Array. It studies the ionosphere and watches for transient events that change in brightness in the sky. Each year, this instrument collects 6,000 hours of data in its 18 antennas. This data was recently used to try and spot a weird object that was discovered using a radio array in Australia. Digging through VLIGHT's data, researchers determined the weird object is something we didn't know could exist, a slow rotating neutron star with powerful radio emissions. When your average star dies, it expels its atmosphere, and what's left condenses and cools over time. Larger stars, not the largest, just your really above average stars, instead implode and blow off their outer layers as their core collapses down into a neutron star. With the right conditions, strong magnetic fields can form, and sometimes that will mean a newborn pulsar, and sometimes, somehow, some become magnetars with massive magnetic fields. In VLIGHT's data and other historical data from other systems, this team found evidence that this object, cataloged as GPM J1839-10, had been rotating every 22 minutes, emitting 5 minutes of radio waves during that rotation. This work is published in Nature and was led by Natasha Hurley-Walker. Her fellow researcher, Simona Giatucci, points out, quote, "This enigmatic object has been hiding in the data for decades. We just did not know we had to look for it until its discovery by the Murchison Wide Field Array," end quote. Fellow researcher Tracy Clark points out, "Findings like this are exciting because they highlight the gaps in our understanding of the physics of these extreme stars known as magnetars," end quote. We don't just find new stars by looking for long periods of time for things that suddenly change in new and unusual ways. Although I have to admit, I'm partial to all those stars that flicker and flare and vary in the night. We additionally find new kinds of stars by looking fainter than ever before. Not everything is bright and not everything is near. Sometimes we only find things when we build new telescopes that are more sensitive than anything that came in the past. And guess what? We have that new telescope. In a new paper in the Proceedings of the National Academy of Sciences, researchers note that 3 objects initially identified as galaxies might instead be massive stars that are largely composed of dark matter and are emitting light due to the annihilation of dark matter in their cores. According to the paper, quote, although made almost entirely of hydrogen and helium from the Big Bang, they form at the centers of protogalaxies where there is a sufficient abundance of dark matter to serve as their heat source. They are very bright, diffuse, puffy objects and grow to be very massive. In fact, they can grow up to be 10 million solar masses with up to 10 billion solar luminosities. End quote. If, and this is a big if, their interpretation is correct, it just might be that some of the first stars were so massive they seeded galaxies. This is a new idea and fascinating, but it is early days and we look forward to seeing more observations and more papers on these new results. And when those papers are published, we'll be here to bring them to you on EVSN. For now, it's time to go to break. When we come back, we're going to look at the tilting of worlds and the flowing of alien rivers. Stay tuned. One of the recurring themes of this show is the possibility that Mars and Venus may have once been habitable planets at the same time as Earth. We don't yet know why Venus became so uninhabitable, but we understand to a degree what happened to Mars. Put simply, it didn't hold on to its atmosphere and cooled off and dried out. This is only part of the story, however. Even if Mars was larger and able to better hold on to its atmosphere, its environment still may not have been conducive to the long, slow evolution of advanced life and even cultures that we see here on Earth. Again, the reason can be put simply. Mars doesn't have a large moon, and this means its environment radically changes on timescales as short as 100,000 years and as often as every few million years. While that may not seem like extremely long durations, humans in one form or another have existed for 1 million years. Dinosaurs last stomped the Earth 66 million years ago. The timescales of humans and life, it needs to be stable across millions of years to allow evolution. But Mars' tilt changes from 15 to 35 degrees over just 5 million years. And with this change, wild changes in the distribution of ice and even dunes and other geologic features has occurred. We understand a lot of this from computer modeling, but sometimes we get lucky and find ways to measure the changes through observations. From orbiting platforms, we can measure the signals of buried ices from past glacier eras, and we can see the riverbeds of past water flow. Our theories are largely built from this orbital data, and the rovers and landers let us confirm or update our theories based on their ground truth observations. In a new paper appearing in Nature and led by Zhejian Liu, researchers using data from China's Zhurong rover study how the signature of ancient dunes points to a massive change in wind direction. While traveling across Utopia Planitia, the rover observed landforms consistent with the region once being home to dunes that were formed and moved under the influence of northeasterly winds. These dunes compressed into the sediments that have since been eroded away under the influence of northwesterly winds. This kind of they were built and they were eroded change in wind patterns is consistent with a 70-degree change in typical wind direction. This is like saying the wind in the Midwest shifted from primarily west to east to primarily south-southwest to north-northeast. It is believed that this change came at the end of the last Martian ice age, 400,000 years ago. And it matches what we hope to see. And with more work, it will let us better understand Mars' past even further back in time. 3.55 to 1.8 billion years ago, Mars was wet. And what happened then? Well, that's what we really want to know. Researchers have named that era of Mars Amazonian. According to research team member Li Xunla, quote, understanding the Amazonian climate is essential to explain the current Martian landscape, volatile matter reservoirs, and atmospheric state, and to relate these current observations and active processes to models of the ancient climate of Mars. Observations of the current climate of Mars can help us refine physical models of Martian climate and landscape evolution, and even form new paradigms. End quote. The remnants of ancient dunes aren't the only place where we see records of Mars' past climates. Mars Perseverance rover is currently traveling along a dried river delta and sampling rocks as it goes. Rivers are both awesome and terrible. On one hand, there's no way to know if any one rock formed entirely locally. On the other hand, riverbeds are full of rocks that came from upstream and rocks that are formed from a conglomeration of rocks that came from all sorts of different places. And this means that Percy is able to sample rocks and conglomerations of rocks from a variety of places on Mars from one central location. As it roves, Perseverance is sampling rocks that we hope to one day bring back to Earth. On June 23rd, it collected its 20th rock sample. Currently, a Mars sample return mission, constructed in collaboration between NASA and ESA, is in the design phase. But in early July, the U.S. Senate made it clear that if the mission can't be done for its estimated $5.3 billion, maybe NASA shouldn't do it. This wasn't good news. According to reporting by Eric Berger on Ars Technica, the mission is now looking to come in closer to 8 to 9 billion, which is not even close to 5.3 billion. Not even close. It isn't understood if NASA will cancel the mission or, as we've done before with so many missions, fight to find ways to keep it going. This could potentially mean cannibalizing funding to many other projects for the sake of retrieving one set of rocks. It's very hard to understand how to balance the benefits of processing rock samples in the massive labs of Earth against all the other science that can be accomplished for that price tag. While the U.S. Senate doesn't want to support a mission over $5.3 billion, NASA isn't doing this alone. As planned, Mars Sample Return is a joint mission between NASA and ESA, and other nations, including China, Russia, and Japan, have all considered their own missions. There's the potential for ESA to cover more of the price tag, or for more agencies like Japan's JAXA to partner on the mission and lower our costs. I'm very glad that I am not the person making these decisions. No matter what happens, there are going to be people who are disappointed. Luckily, the rocks Percy is collecting can't go bad. If the mission is canceled now, there is still hope the science can be done in the future. It is even possible that someday humans will pick up the samples Percy is collecting and bring them to a lab we take with us to Mars. The future has many options, and whatever path things take, science will be possible. Until then, we watch from above and rove with robots when we can, and we learn. And really, we can learn a lot. New research published in the Proceedings of the National Academy of Sciences, led by Samuel Birch, demonstrates a new method for determining the strength of ancient rivers. From images, we know rivers have flowed on Mars and Saturn's moon Titan. From living on Earth, well, we've had rivers. We still have rivers. This new research looks at how both fluids and sediments are carried across a world, how wide and steep a river may be, and then combines these image-based measurements with info on each world's gravity to estimate the power of the rivers. The calculations can be confirmed here on Earth and used to look at modern Titan and to try and understand past rivers on Mars. This research finds that the rivers in Gale Crater, home of Curiosity River, likely flowed for at least 100,000 years. In Jezero Crater, where Percy explores, the river flowed for at least 1 million years. Well, Titan has a much lower gravity than either Mars or Earth. This research also found that its methane ethane rivers should be wider and flow along more shallow slopes than rivers with the same flow of water on Mars or on Earth. It's unclear when we will get the chance to verify the results of this model by directly measuring river flows on Titan. But it's remarkable to think that that kind of otherworldly science will one day be possible. At least I hope this kind of future exploration will be possible. Right now, a lot of planetary science money and energy needs to be directed at understanding our planet. And that exploration just might have to wait. That exploration of other worlds. It's not the same priority as our world. Up next, we look at the impossible to ignore Earth science results of the past couple of weeks. Stay tuned, or fast forward about 12 minutes to jump straight to this week's tech and rocket news if you already know about the mid-ocean currents, the 1.5 Celsius temperature increase, and the sinkholes in Siberian tundra. There's a lot going on to discuss after the break. As human beings, we have infinite capacity for empathy. We also have the capacity to be blind to what is going on in the world around us. This is why, at a certain level, some people see the Sarah McLachlan ASPCA ads and donate. Some click to another site as fast as possible, and others can just ignore them. This complex reaction to emotional topics is why even our team struggles to communicate climate science. Put simply, there are human consequences fundamentally entwined with the discoveries being made. And to understand climate science is to force yourself to also understand those human consequences. As I pulled together the content for this story, I watched the hourly weather predictions for southern Illinois wildly change as meteorologists struggled to understand how to foretell the future from the patterns of temperature, pressure, and humidity seen by weather networks. There was a chance we'd have tornadoes, and there was a watch in place. There was also a chance we'd have clear blue skies and negligible wind. And every hour or so, the predictions changed. It was fine. It was fine. For a while, computer models had gotten really, really good at predicting weather. But right now, we're contending with oceans that are hotter, poles with less ice, and many other global changes that have wrecked the frameworks those models were built upon. For the next few minutes, we're going to look at some of the biggest news in climate change today. And I'm going to encourage you to not turn away. But if you do, I totally get it. We're going to start with a story 20 years in the making. In February 2003, the journal Nature ran a story on the Atlantic circulation pattern, written by Stefan Ramstorff. This article summed up what we understood about how the Atlantic circulates water from tropical regions northward and then cold water from warm Arctic regions southward. This circulation pattern and the prevailing winds together explain why London, England can be further north than the Canadian city of Calgary and have palm trees and winter rain, while Calgary is more known for brutal winters and summers with highs in the low 70s. As this 2003 article points out, models show that changes in circulation could change European temperatures by up to 20 degrees Celsius or 46 degrees Fahrenheit. The easiest way to collapse those circulation patterns would be to dump too much fresh water, such as from melting sea ice or glaciers, into the ocean. Ramstorff was the person to know just how worried we needed to be. In a September 2002 paper in Nature, he wrote a review of the ocean circulation and climate during the past 120,000 years as part of an issue with a series of review articles on climate. It was an amazing issue that I still remember reading. It was the first time it was really brought home to me that we were on the edge of taking our planet into a new climate regime that is beyond anything our planet had ever seen. As written in a different article by Lee Kump, the lack of an adequate ancient analog for future climates means that we ultimately must use and trust climate models evaluated against modern observations and our best geologic records of warm and cold climates of the past. Armed with an elevated confidence in the models, we will then be able to make reliable predictions of the Earth's response to our risky experiment with the climate system." End quote. Back in 2003, the interactions between greenhouse gases, geology, and our changing sun were still being debated. And while climate change was generally accepted among scientists, the role of humans was still being debated. I have to admit, a lot of us believed that as soon as society would accept that the release of greenhouse gases was doing things to the environment, we thought there would be a global action to do whatever was needed to reverse the heating of our planet. After all, as a child of the 80s and 90s, I lived through both the era of really big hair and ozone layer destruction, and the era of really flat hair and the elimination of chlorofluorocarbons. And that elimination led to the subsequent healing of the ozone layer. On July 25th of this year, 2023, Ramstor's article was cited in a new paper in Nature. Written by Peter and Suzanne Detzlev, this article is titled "Warning of a Forthcoming Collapse of the Atlantic Meridional Overturning Circulation." This article cautions that weakening of the circulation patterns are already starting to be seen. While they estimate full collapse is unlikely to occur in this century, it may happen before today's children grow old, and while their children are the leaders of a starkly different world. In this paper, they explain, and I paraphrase, when complex systems, such as the overturning circulation, undergo a structural change in the dynamics, the previously stable state ceases to exist, and the system moves to a different stable state. We are currently seeing that structural change, and if we aren't careful, we'll see that new stable state, and it may not be survivable. Locally, many of us are seeing weather that is more extreme, wetter, drier, hotter, colder. If something could be more extreme, it probably has been. While we here in the Northern Hemisphere swelter under 100-degree Fahrenheit summer temperatures and complain, it's at least normal to be hot in summer. Currently, it should be the deepest of winter in the Southern Hemisphere. Due to the slight ellipticity of Earth's orbit, southern winters are generally a bit colder than northern, and Antarctica is a bit more extreme than Arctica. Currently, temperatures in South America are also nearing 100 degrees Fahrenheit. On August 1, it reached 86 degrees Fahrenheit on a winter's day in Buenos Aires, where the normal high is just 58 degrees Fahrenheit, with other higher temperatures being measured in the Andes. In some places, the temperatures reached all-time highs. Not all-time highs for that particular day of the year, but rather the all-time highest temperature ever measured was measured in winter. Along with these South American highs, Antarctica is seeing less formation of sea ice, and massive icebergs, one the size of Greenland, are breaking away from the continent to melt in the ocean. While South America bakes, Slovenia and Beijing regions flood, and hail bombards locations scattered around the globe. These dramatic excursions in temperature are being caused by pressure and temperature changes in the atmosphere that allow heat domes and Arctic domes to plunge places into extremes for days and sometimes weeks at a time. These weather events are a taste of what our world looks like when the average temperature rises globally by 1.5 degrees Celsius or 2.7 degrees Fahrenheit. That is the temperature change we want to avoid. But in the month of July 2023, 1.5 degrees Celsius is the change in average temperature the world experienced. Back in 2003, when I read that set of review papers, researchers did everything they could to understand all the ways that greenhouse gases are entering our environment and how changes to our environment will in turn change how our planet absorbs and reflects heat. We got a lot of things right. We understood that ice is really good at reflecting light, and the loss of ice would accelerate the heating of our world as more light is absorbed and able to warm waters and warm land. We also totally missed a bunch of things. Permafrost is melting in ways we never imagined and opening up amazing sinkholes in places like Siberia. The largest of these melts is Batagaka crater in Siberia. Newly posted drone footage highlights how this feature is literally unzipping the Siberian landscape. Today, the feature, which is also called the doorway to the underworld, is roughly a kilometer long, 100 meters wide, and it's growing about 10 meters a year. While paleontologists are getting an amazing opportunity to study freshly revealed ancient plants and animals, climate scientists are seeing massive volumes of greenhouse gases released from melting ices and the decaying of now thawed plant matter and animal matter. It's estimated that up to 200,000 years of historical climate records are revealed in the layering of the revealed landscape, as well as revealing potentially previously extinct viruses and bacteria, and a worm. Researchers actually revived a roundworm that survived frozen for 46,000 years, 40 meters below the surface in Siberia. Right now, it is, I hope, impossible for people to not acknowledge the cost climate change is having. From the literal costs of heating and cooling to the human costs of dangerous flooding, tornadoes, and other weather extremes, this is a cost our society can't afford. Folks, it's time to do what we did with the ozone hole. It's time to change international rules and abide by the changes and find ways to fix the harm we have done. We're going to need to do more than update our AC and get rid of our hairspray. But if we have a will, we as a planet just might be able to return our world to the stable place we knew before. After a break, we'll be back to look at all that's new in space exploration. Stay tuned. I don't know about you, but there have been a lot of random times when I or someone near me has said, someday archaeologists are going to have a field day with that, as we looked at everything from satellite dishes to really weird statues and wondered what future people would think. But archaeological exploration of modern technology may not have to wait for the far future. It's reasonable to think someday in this generation or the next, researchers will very carefully confirm if the Apollo astronauts' footsteps are still on the moon. Researchers may track down the crash site of the Beagle 2 on Mars and make a final determination of why it crashed. They may even predict the rate at which Spirit rover is buried beneath dust and sand. In a new paper in the journal Geoarcheology with first author Justin Halcombe, researchers suggest these future studies be called planetary geoarcheology. According to Halcombe, quote, "We feel that all material currently existing on extraterrestrial surfaces is space heritage and worthy of protection. We should begin tracking our material record as it continues to expand, both to preserve the earliest record, but also to keep a check on our impact on extraterrestrial environments. It's our job as anthropologists and archaeologists to bring issues of heritage to the forefront." End quote. As we move forward, planning new missions to worlds we've already visited, it will become necessary to balance the needs of science against the needs of preservation of historical sites. This suggests that tomorrow's planetary geoarchaeologists should begin training today. Further, this work suggests, quote, "Geoarchaeologists on Earth can lay the foundation for that work, including advocating for laws to protect and preserve space heritage, studying the effects extraterrestrial ecosystems have on items space missions leave behind, and conducting international discussions regarding space heritage, preservation, and protection issues." End quote. And speaking of spacecraft, next up, I'm pleased to welcome on aerospace correspondent Eric Mattis for this week's Tales from the Launchpad. Hey, Eric.
Hi, Pamela. This week was a week of highs and lows. SpaceX launched the biggest commercial satellite ever, but the last Centaurus 230 also launched, plus a new radar satellite for Singapore and a bunch of Starlink and Chinese launches. First up is at Large ComSat. On July 28th, SpaceX launched Jupiter 3, aka EchoStar 24, on a Falcon Heavy into a high perigee geostationary transfer orbit. The launch was delayed several times, first for weather and then an abort 1 minute before launch. The abort was determined to come from a faulty valve responsible for pressurizing the liquid oxygen tank on one of the rocket's side boosters. It was replaced and launch was rescheduled. Jupiter 3 is the largest communication satellite ever launched, weighing in at a little over 9 metric tons. To get to its high orbit, the Falcon Heavy's core stage was expended, as has become routine for Falcon Heavy launches. It's not impossible to recover it like they do with the side boosters, but most Falcon Heavy launches that could see the center core recovered would probably be better served by an expandable Falcon 9 Extend, since that rocket is much cheaper. The side boosters were originally slated to be recovered downrange on both of SpaceX's Atlantic-based drone ships, but the mission profile was changed to return to launch site landings to accommodate SpaceX's frenetic launch schedule. The barges were instead used to catch the first stages of two Falcon 9 based Starlink launches the week before. The land landings were successful, as were the three burns of the second stage that delivered the satellite into its orbit, 3.5 hours after launch. The satellite's owner, Hughes, made contact with the satellite a few minutes later. The next launch since the last show was DS-SAR on an Indian PSLV rocket on July 29th. DS-SAR is a radar satellite belonging to the Singapore government. It will also be used by the commercial company ST Engineering. The radar instrument was made by an Israeli company. The PSLV also carried 6 small satellites were developed by different universities in Singapore. On August 1st, the final Antares 230 Plus sent the Cygnus NG-19 Laurel Clark to the ISS. It carried 3,785 kilograms of payload, most of which were supplies for use inside the station, along with a small number of components that will be used outside the ISS. You can read about some of the experiments set up on Cygnus at the link in our show notes. This is the last Antares 230 because deliveries of the rocket's engines were cancelled by the Russian authorities after Russia was sanctioned due to their unprovoked invasion of Ukraine. Besides the rocket's engines no longer being available, the factory in Ukraine, where the first stage tank for the Antares was manufactured, was destroyed by the Russians in 2022. Northrop Grumman has a plan to build the new first stage for the Antares rocket using a slightly modified stage made by another company, Firefly, which is being developed for Firefly's Beta rocket. Until it's ready, Cygnus will be launched on a Falcon 9 rocket, putting the USA in the uncomfortable position of having its only active crew spacecraft and both active cargo spacecraft dependent on the Falcon 9 rocket until mid 2025. Also, since the last show, there were 5 launches by China we don't know a lot about, and 3 more batches of relic satellites. We keep track of orbital launches by launch site, also called spaceport. According to rocketlaunch.live, so far this year, the USA has had 57 launches, China 31, India 6, Kazakhstan 5, New Zealand and Russia each have had 4, French Guiana and Japan each have had 2, and Israel, North Korea, South Korea, and the United Kingdom each have had 1. Of those 115 launches, there have been 5 failures, reminding us that space is hard.
Thanks, Eric. Before we go, I want to share what may be the most questionable image so far taken by JWST. At first glance, this is an image of glowing gas. Specifically, this is the forming stars Herbig-Haro 4647. This image was taken to allow researchers to understand new details of star formation. But it's super hard to get JWST data, so folks are going to study every pixel, looking for new science. And in the lower portion of the image, some of those lit up pixels are making researchers question just how this unusual mark made its way into the sky. Well, some within our Discord community conjectured the simulation has an undefined variable that has been handled poorly. The reality is this isn't a case of unsanitized strings. Rather, we're seeing 1 or possibly 2 distorted galaxies. This bit of punctuation is your daily reminder that given enough time and enough space, the universe can and maybe will create just about anything. And that is it for now. If you'd like to join our Discord community, go to evsn.tv to find your invitation link. I hope to see you online. Good night, everyone, and remember to go out and look up.